we start with a very simple case. Let's say the simplest case possible is that we have, let's say, two variables. Okay, we have two variables. Let's say one is x and one is y. Okay, if you can make this as a real-time case, like a very simple problem which is solved is that supposing we take the age of a person, and from this age we try to find out what could be his height. Okay, so obviously this is not sufficient. We should have more variables like whether he is a man or a woman and things. But nevertheless, let's take a very simple case where, so supposing we have two variables, x and y. So given the value of x, we want to predict the value of y. Okay, so I was giving an example. Supposing x is age of a person and y is height of a person. So if I give an age of a person, I want to determine what should be his height. This is, by the way, a very popular problem which has been solved by the brother of Dalton. Okay, the Dalton is that theory of evolution person. Okay, nevertheless, now this is a very simple case. So what we can do is that, supposing we have the data, we have data regarding what is x and what is y. So based on this data, we will do a model which will be using which, when I give any value of x, it should tell me what is the probable value of y. So that is what we will do. So this is a typical problem which we solve using linear regression. So what we will do in linear regression is that we will draw a graph. Let's say we draw a graph like this, and on this graph I will plot all the points what I have from x and y. So this is my x and this is my y. So I plot a graph. So supposing for this value of x, this value of y is here. So similarly, I will plot a graph where I get all these kind of points across the graph. Okay. Now what I do is that once I start applying linear regression, I will have to find a line through these points such that the line is the best fit for this particular set of data. So let's say we take arbitrarily, how machine learning works is that like this. We take arbitrarily any line. Okay, we take any line arbitrarily through these points, and what we do is that for every point, I know that this is I will change the color of the pen. So I know that this is the actual data what I have received, right? And these are all the actual data what I have got in my from the past experience. But this is the line which I have drawn, which is supposed to give me the prediction. So on this line, if I give any data of x, it should tell me what is the point in y, right? So how we achieve this line is that for each of the points, what we do is that we find out what is the error, what it is causing, right? So you see, according to this line, the value of y for the given x should be here, but the real value is here, right? So the real value is here, whereas my prediction is telling me that the value should be here. So now this distance, what is there between these 2 points, this is the error term. Okay, this is my error. So similarly, I will find the error for all the points. Okay, so I will find the error for each of the points, and I will find out what are the errors. Now you notice that the errors can be either positive or negative. Sometimes I will overestimate, sometimes I will underestimate. So I have the errors which are positive and negative. So if I sum up all the errors, what can happen is that the errors might vanish, because the positive and negative will cancel each other out and the errors might vanish. So instead of doing that, what we do is that we take the square of the error. So if you take the square of the error, then what happens is that all the error terms becomes positive, right? So now if I add up the error terms, there is no question if the errors exist, then there is no question that I will get some value for the value of error square, right? That will be a positive number only. So now what we try to do next in linear regression is that and how machine learning works is that I will take any line and I will find the error for every point from the data what I have got. I will take that and I will sum up all the errors. Okay, after summing up all the errors, I will divide this by the total number of terms which I have got. Now you see what this has become is a very popular term you must have heard about. This is known as mean square error. This is very intuitive. This is the error, this is the square of the error, and this is the mean of the square of the errors. So this is the mean square error. Okay. Now what we do is that, what the machine will try to do is that, it will try to minimize the mean square error. Okay. It will try to minimize the mean square error. So if I get a line through these points such that the mean square error is the minimum, then that line is the best fit line for predicting for this set of data. So that is what is machine learning for linear regression. So what we are trying to do is that we are trying to find a line through these points such that the mean square error is the minimum. If the mean square error is the minimum, then we can consider reasonably with some amount of confidence, we can say that a prediction made based on this line is going to be the best prediction what is possible for this set of data. Now a little bit further if we go, if I find a line, we know that the equation of a line is y is equal to ax plus b. This is the equation of any line, right, on a two-dimensional scale. So from this equation, we normally, you will notice that in machine learning, we will write this as y is equal to beta 0 plus beta 1 x. Now here, a few things are very significant. One is that this term is known as the intercept. It will become clear why they write it like this. It will become very clear very shortly. So this is known as the intercept. Intercept. Now it is very easy to understand the intercept basically because the value of intercept beta 0 or a in this equation is that when x is equal to 0, value of y will be here. So what is the value of y when x is equal to 0 is basically the intercept. Okay. And second thing is that this term is known as the slope. Now this is also very simple to understand in the sense that this means that for any point on the line, if I increase the value of x by 1 unit, what will be the increase in the value of y? So if I increase the value of x by 1 unit, how much the value of y will increase or decrease? The line could be like this also. Okay. So that is the slope. So slope basically indicates the marginal increase in y based on a unit increase in x. So these are the two terms. Now what happens is that we will not have a problem where we will have just one independent variable, and of course we have to have one dependent variable. This will remain the same, but we will not have a problem where we will have just one independent variable. So we will have, let's say, n number of independent variables. So if we have n number of independent variables, then what our linear regression equation becomes is that it becomes y is equal to beta 0. We will still have only one intercept plus beta 1 x plus beta 2, this is x1 plus beta 2 x2. Like this, we will continue till we have beta n xn. Okay, so this becomes my linear regression equation. So now the problem, we cannot visualize this on a two-dimensional or a three-dimensional space because this is n dimensions. But nevertheless, the concept remains the same, where I will have the various axes. In this case, it will be X, Y, Z, and we can only go up to 3 dimensions. We cannot go beyond that. But there will be somehow some line generated through this, which will have a point where it will cut the different axes. That will be the intercept, and there will be proximity from all the lines from this line, something like this. Okay, so that is the whole idea of linear regression. Does this make it clear what we are trying to do? So
Yes.
machine learning.
Yes, Partha. Yes.
Thank you. Machine learning means what? I will know the values of x1, x2 up to xn, right? So if I put a value of x1, x2 up to xn, I should get a prediction for what should be the value of y. That is what we're trying to do. Correct?
Yeah.
Okay. So that explains linear regression. This is how the algorithms work. And what we are trying to do, we have discussed the other day what is random forest, right? So random forest, we are trying to do classification with random forest. So basically the same thing. We will give n number of independent variables. Based on the n number of independent variables, it should give me a prediction whether what should be the output of this prediction, whether it will be 1 or a 0 in case of a binary classification. So that will say that, okay, for the file is contains a malware or file is a good one without any malware. So that is what we're trying to do. Okay.
Yeah, yes, Partha. This linear set I'm able to clearly understand. But the next sets you have explained, right? Random and another one is the vector based one, right? Two models you have explained, right? So what is the advantage over this linear progression?
Okay. What is the advantage is like this. The thing is that, see, linear, this is regression, right? Regression means I should have a problem where I have to make a prediction for a continuous variable. Okay. Like we discussed the previous time, supposing now I have the data regarding what is the temperatures in Chennai for the last for every day of the last 10 years. Supposing I have that. Okay. Then of course I will have other data also. What was the date when the temperature was recorded, and from the date of the recording I can find out the day of the week or the day number of the year, and so many things I can decipher from just one date. Then supposing I have this much data only, I have the date and I have the temperatures of a particular day. Now my problem is that I want to find out on 10th of June 2021 what will be the temperature of Chennai. Now this is a typical problem which can be solved using linear regression. Okay, so this is the regression problem, but we cannot do regression for a case like we are solving, where I have to determine whether a file is a good one or contains a malware. Now I require two kind of predictions in this case. That is a binary set. One value of the output should indicate it is a good file, and one value of the output should indicate it's a bad file. Now here we get into a little bit more mathematics in this regard, and I will try to explain this to you. What we typically do in this case is that you will notice, you will come across this term very frequently, is that we have to use something known as logistic regression. Okay, logistic regression is not regression. This is a classification algorithm, but somehow the term is logistic regression. It has got a reason why it is called logistic regression, because basically it also is a form of regression on. Now in this logistic regression, what we have is that we have a function called sigmoid. Okay, this is what we will be requiring. This is what we will, in the explanation for random forest also I didn't get into this mathematics, but this is what it is. So we have a function called sigmoid. The sigmoid function is very simple. It is equal to, it is written as 1 plus 1 by e to the power z. Okay, e to the power minus z. So this is a sigmoid function. Now, if you draw a line of this function, what will happen is that this line will be something like this. Okay, this line will be something like this. Now, this point is going to be 1, and this point is going to be, it is going to be 0 actually. This is not correct. We should have the line from here. This is going to be, this is the x-axis, and this is my y-axis. So if you draw a line for this equation, the line will be something like this. Now you notice here, now when I solve any problem where I have, again, let's say for a simplicity case, I have one x and one y, and if I get an equation like this and given a value of x, I try to predict a value of y, so I will get some value of y which is, let's say, here, right? Or the value of y will be here. But the important thing to notice is that the value of y will always lie between 0 and 1. So this is 0 and this is 1. Now, what we do in our case, in machine learning case, is that we take a threshold mark. Okay, we will take a threshold mark. Supposing I say my threshold mark is here, and the threshold mark is 0.6. So then I will say that anything above 0.6 can be considered as 1, and anything below 0.6 can be considered as 0. So now you notice here, very importantly, supposing I use this regression and I determine a value of y. If the value of y is greater than 0.6, which is my threshold, this I have set. Okay, and then I will say the value is 1. So I can say that if my regression gives me output where the value of y is greater than 0.6, I will say the file contains a malware. If the value of y is less than 0.6, I will say the file is a good file. So you see, what is happening here is that I'm able to make a mechanism by which I can get two values, either 0 or 1. So 0 will be one class and 1 will be one class. So basically what I have done is that through this equation, I have generated a mechanism to make a binary classification. Does it clarify or confuse? Hello?
Yeah. Yes.
Okay.
Yes.
Yeah, I am okay. Yeah.
So this is what we will do. Now, extending upon what we have just discussed. Now, what you notice here is that we discussed about linear regression, right? So I was trying to draw a straight line through these points, but I need not have to take into consideration that I will always have an equation of this form. Supposing I say that I am ready for a polynomial equation. Okay, I am ready to take a case where I can take a polynomial equation. I can say that supposing I want my equation to be y is equal to beta 0 plus beta 1 x to the power 3. Okay, supposing I am agreeable to, then I will not get a straight line. In this case, I will get a line which will be something like this. Actually, it will not be like this. This is for y is equal to x squared. But in case of y cube, it will be a hyperbolic line. So it will be the opposite direction. So supposing I make it square. Okay. Now, so I will get a line like this. But here again, the principle is the same. Once I get a line like this, I will again try to find out the distance from the actual value and the predicted value, and try to minimize the sum of the square errors. Okay. So if I now go for a higher degree polynomial, then I can get a line like this, which will be very close to the points. Now, what happens is that, again, we were discussing the problem of overfitting, right? Supposing I make a line which goes very close to all the points in the trading data set, then this can be a very complex equation what I form, but based on the training data, it may find a line for me which will be very good in predicting based on the training data. But if I give a new data point somewhere here, it may produce a nonsense output. So if that is the case, then we typically say that our model is overfitting. So you should, the essence of machine learning is that Yes, we always look for a very complex, what do you call, solution to a problem, because the solutions are always complex. But still, we have to ensure that there is simplicity in the model. Simply because if we make a very complex model, the model may work very well in on the training data set, but on the real life data, the model will behave absolutely irrationally. So the essence is that we should always find a simple model.